They're too lazy to show up, so you have cookies.
Oh yeah, the more for us.
They have to piss up and make sure they know this. Is Dan gonna do something about the hear noise? Or just gonna live with it?
Oh no, we got to turn it down. Yeah, we can get rid of the YouTube.
I'll take care of that.
Okay, all right, so here we are, it's 2:00. We're ready to start the afternoon session of day 2, Sunday, October 29th, 2023. We have Gavin McGrath who's going to talk to us about epoxy putty tools. So, Gavin, if you're ready to go, let me get the share screen ready. You can take it away.
Yeah. So I apologize if this is sort of thrown together. I've been very busy with studying for exams and stuff at the moment, but this is my presentation on what I've found with epoxy putty tools for mirrors. So epoxy putty tools, the epoxy putty comes in 2 separate parts. It's sort of like a stiff putty that you need the 2 parts together equally, and you apply it to whatever sort of disc. So like a plaster disc or a steel disc or whatever tool you were using all along for fine grinding or for rough grinding. And then you press it against the mirror to gain contact with the mirror. And then you let it cure, and it needs to be pressed against the sort of a damp mirror surface so it doesn't stick to the mirror. And then you let it cure before you use it. And then that's sort of a picture of one that I used on one of the 6-inch mirrors that I did. And I decided to use epoxy because at the time of making my first mirror, I didn't really know what I was doing. I didn't have any pitch at the time, and I'd sort of become familiar with it through building model aircraft. I was using it for a filler and for vacuum forming certain parts, so I knew what its properties were, and I realized it was quite stiff when hard, but it could be dented with a fingernail, and was quite soft to cut with steel, like scalpel blades or whatever. And I realized I might as well try it to see if it would polish a mirror. So I quickly made up a tool, and I found out it would polish glass. And other people on modeling forums have said that you can mix different brands of epoxy together, like Milliput is what I use. But if you mix Milliput and green stuff, you might end up with sort of a softer substance, which could be usable, which could be like explored, might end up as a better polishing compound, I guess. And my experience with epoxy, I've done a 6-inch
I think it's more on you.
F7.3, and that was from a 10 micron finish or so. I've done a 6-inch F3.6 from a 10 micron finish. I attempted to do a 12-inch from a polished glass finish, but that didn't work out as well because the epoxy didn't have time to work against the glass and pick up contact as well. And I started at 10.75-inch F2.9 with an epoxy tool, but this time I started it way earlier. I started it at 600 grit, so about 30 micron. And I found it would do that as well. So I found out the epoxy can be used for fine grinding, and it actually works quite well for fine grinding. It doesn't give you as much scratches as tile in the fine grinding stages, and this was found out by another person who tried it out as well. And it's quite easy to clean up and stuff instead of like pitch can get kind of messy. Epoxy is cleaner in that aspect. Sort of from talking with people in the group, the observational astronomy Discord, they were quite interested in its use for large because a single tool could be used as soon as the mirror is slumped. A single tool could be used for all of the fine grinding if the slump is good enough, and right the way to the polishing. And this could eliminate the need for tile or anything like that. And it might even do as parabolization. However, I don't know yet the exact quality of a figure it can do, because the ones I've done were sort of my first mirrors, so I can't quite say for sure the quality, and that's based on my skill, not the epoxy. And due to the compliant nature of epoxy, it could allow for further fine grinding on a sort of large thin meniscuses without with reduced risk of scratching. Sort of the limits of epoxy for tooling have yet to be sort of explored, as it's only really been done by me, and I'm sort of new to telescope making in general. But it's quite promising, and a lot of the people that I've spoken to have been interested in the idea of using it, at least for fine grinding, to eliminate tile usage and scratches, I guess. However, it does have some drawbacks. It could be quite expensive in comparison to pitch. However, if you're removing the need for tiles, there could be that aspect to it. And it's quite stiff. It's quite difficult to form to the mirror. So you need to put quite a bit of pressure on it so that it picks up the curve of the mirror. And I don't know how this is scaling for, I've only done like 6-inch mirrors with a 3-inch tool and a 10.5-inch or 10.75 inch with a 5-inch tool. So I haven't really done anything bigger than that. So I guess if you were to do bigger tools, it would have to be done in sections. And you're working against its curing time then. But I suppose if you did sort of concentric sections, maybe you could do something like that, or even paneled sections. And I suppose the unevenness occurring due to the sections would be ground out anyway as you're using it for fine grinding. It can't be reused like pitch, which is another drawback. And also it takes quite a bit of effort to just knead the epoxy together to sort of by hand. I'm not sure if it can be mechanized. It needs to be kneaded together by hand. And this would get very tiring for larger quantities of it. And it could be quite a good option for beginners instead of pitch, because like as what I've done, because it's quite easy to use. You don't need to buy pitch, and it's simple. It's sort of straightforward. You can sort of, with a 6-inch mirror, which is what most beginners start out on, you can just sort of form it against the mirror and polish away, and it'll figure the mirror just fine. And you don't have to go buying pitch or dealing with pitch in any way. And they could, if they are sort of developed further, they could reduce the number of tools needed for sort of a well-made meniscus. You could start with an epoxy tool. This could negate the need for a tile tool. And if they're used for up until even just roof polishing, you might only need to use pitch for a short while instead of for the entire polish. However, this is all sort of untested, as I've only done couple of mirrors with epoxy, but it could be quite interesting to look into, I think. And
So Gavin, I'd like to ask a question.
Yeah.
So it's the fully cured epoxy on your tools.
Yeah.
Is it as hard as the glass of the mirror or a little softer?
It's softer. It can be cut quite easily with a scalpel blade, for example. And
Okay.
when it's wet, if it's constantly wet, it seems to be softer again. It can be dented with a fingernail, sort of.
Oh, okay.
It's
Yeah.
quite stiff.
Okay. You said that. Okay. So when you're fine grinding using those grits, the epoxy is wearing away just like the glass of the mirror is wearing away.
Yeah.
Have you had to reapply epoxy because of that?
No, I haven't had to reapply epoxy. I applied it in about a 3 millimeter layer, and it hasn't worn through. However, I'm not sure. Obviously, if you're doing fine grinding from a further back point, like 600 grit or 400 grit, you'd need more of it.
Okay.
Gavin, can I ask a question? This is Jeff Baldwin.
Yeah.
Have you done mirrors with the traditional methods and done it with this, or have you only done mirrors with this method?
Oh, I have used pitch for the 12-inch, which started out, which I received as polished glass, and I initially figured with epoxy. That was kind of a rough surface, so I'm currently in the process of refiguring it with pitch.
So you've experienced both methods and can compare the two.
Yeah.
All right.
However, I'm still new to telescope making in general, so my experience is limited in general.
Rob Brown here. Gavin, this is really exciting. I love that you're new to this and you're trying things that anybody else in the room would have said, what are you, nuts? So congratulations, and you bet I'm going to try this. I'm not on my current mirror.
No, you're too
But soon.
far into it.
Yeah.
So if you come up with another recipe that makes it slightly softer by using different brands, hopefully you could let everybody know.
Yeah, I will. I'll see what I've got. 2 10-inch mirrors that I'll be testing out different methods with soon.
I think we'd love to see a fully polished out spherical mirror. Don't worry about parabolizing yet. Show us what these figures look like at sphere with a Ronchigram, ideally.
Yeah.
Yeah, that'd be wonderful to see.
Oh, heck yeah.
Yeah, I don't have any sphericals at the moment, and my initial figures were not quite great due to turn down edge and other sort of problems due to my lack of skill with.
It's all about roughness and smoothness. And if it's got a turned edge, who cares? What I'd like to see is it rough or is it smooth? Right. So
yeah,
whatever figure you get
once
it's polished out, shoot a Ronchigram and send it our way. We'd love to see.
As far as I think any of us know, this is new.
Yeah.
And it's very interesting. And yeah, I would be tempted to make use of this if I was getting started on a new mirror right now.
Yeah.
For sure. So yeah, even if your initial results don't look good to you, they'll be very educational to many of us.
And there may be things that can be done to take advantage of it anyway. So
yeah,
if it's a good polishing medium, and it just polishes it out quickly, that may be enough.
Yeah.
Because you still need pitch to figure.
Yeah, because you wouldn't need polishing pads, which tend to peel.
Yeah.
Right.
Yeah.
And yeah.
That's another aspect. Doing most of the polishing with it and then finishing with pitch for the final smoothness and figure.
Yeah.
I might have missed this, but how do you make the epoxy stick to the tool?
Oh, that's what it does.
I mean, it's just intended to stick.
That's epoxy is to stick things together usually, yeah. Yeah,
Did you make that first tool? Was that solid epoxy and no backer on it?
No, the first tool is a steel disc. It's a counterweight off an old telescope. That's why it's got the central hole, and I just stuck a thin layer of epoxy to it.
What's the yellow? What causes the yellow?
The yellow is the epoxy itself, yeah.
Okay.
So it doesn't have to be a solid surface of epoxy?
No, just sort of as you would with pitch or whatever, just sort of apply it to a tool in a thin layer.
It looks like you cut grooves in it as one would in pitch.
Yeah. Yeah, and I cut the grooves just with a scalpel or the edge of a corner of a file.
Was it prior to curing or after?
The grooves can be cut either during curing or after. It works quite well. It's easy to cut with a file or anything after curing.
What got you to do this in the first place?
I just didn't have pitch on hand, and I was just looking at the mirror, and I looked up and I saw the epoxy up on my table, and I was like, it might work.
there you go. I wonder what if. Let's try.
Some big discoveries have happened that way.
Yeah, oh yeah,
Like
F around and find out.
yeah.
or peanut butter and chocolate.
No, no, there you go. Yeah. Well, this is great.
I could see myself casting a plaster tool as I always do, and then doing a few beads of epoxy putty or, center and around the edge just to get the mirror pressed into it, and then add a few more beads, keep pressing until I've got a tool that's basically looks like a tile tool,
Mhm.
with, and
Yeah.
start grinding away.
So you're saying that'll give you your channels and everything that way?
Yeah, building the channels just
Ah.
by virtue of the fact that you're putting it on in gobs like that, because you don't have a lot of working volume, right? And then I could see myself, if this stuff were a good way to polish, then the question is it a good way to figure? And if it can let you do a figure on a slow mirror, can it let you do a figure on a fast mirror? And I already know now that I can sculpt it into whatever pedal shape I want. And I could modify the pedal shape as I go, because I could just add or subtract epoxy
Yeah.
and just keep repressing as the epoxy cures.
But it doesn't flow.
But it doesn't flow. And that's the question. If it doesn't flow, then does it wear? Right? Because pitch doesn't wear, it flows.
Hmm.
But if it wears in a proportion that pitch flows, then perhaps we've got something. I don't know.
Well, further research is warranted.
Research required.
Yeah.
Also, it's not temperature dependent or anything, so you can use it in sort of any temperature at all, and it'll just stay the same, which is another sort of interesting thing about it.
You bet.
Keep posting your progress and failures.
Yeah.
Please.
Any information is worthwhile. Good, bad, or indifferent.
And it'll figure as far, the fastest I've figured is a f3.6, although I reckon the f2.9, if it hadn't split down the middle, would have figured fine with it.
Make a pair of binoculars.
Okay, so you
Wow.
actually did figure. Wow.
Yeah.
Okay, yeah, I missed that too.
Wow.
You figured with.
And yeah,
Mm.
sorry, I'm talking a bit fast. And I always use the 6-inch f7.3. I use that frequently all the time. And that I figured I use it to look at Jupiter and stuff. It seems to be a quality mirror. I don't have any reference for, like, I've never used a commercial f or 6-inch, but this one gives, I'm satisfied with the views it gives. So I guess even from a beginner's point of view for your first mirror, it'll give a satisfactory result in terms of parabolizing and all that.
Well, that's a huge pedestal to stand on. It's your own satisfaction is one level, but given that level of success, there's always somebody who can improve upon it, if not you. And
Yeah, I reckon
this is freaking
because people have
awesome.
been, yeah, because pitch has been sort of tested for a long time, and this is like, if enough effort is put into this, it could be quite interesting.
Mhm. Yeah, now that I've looked at this slide again and that you actually parabolize two mirrors,
Yeah.
that's even way more impressive than I at first thought. So, wow. Yeah, I think this is. Hey, Mel, if you're out there, what do you think about this?
This is Mel, and I think this is quite exciting, and I'm glad someone is pursuing it. People have used plastic in the past. I remember using window screening. Howard, in his book, The Standard Handbook for Telescope Making, talks about using plastic screening. He found that it polished quite well. It left a little bit of a rough surface and a few minor scratches. But that, to me, is actually quite successful, because why can't you just paint some pitch on top of it if you need to go a little smoother, or you find some issue with it that you desire to do the pitch. Pitch maintenance is high. No one really likes to do it. Becoming good at pitch is not something that you want to put on your resume, because you're going to ask how insane are you, you know. So I think this is exciting, and I'm glad that someone is exploring this.
I like the feature of he doesn't care how cold chalk gets.
Yeah,
That's kind of cool.
yeah.
I did have one question. So you presumably tried to sweat and dry. Did you find any magic ratio of water to compound, or did you find it pretty robust, or you know, what are your experiences along those lines?
I was just sort of using water sort of as I sort of felt necessary with the finer grits. I haven't measured ratios or anything. I didn't try it dry or anything, so just sort of water as sort of you would with the grit compound, the grits or the cerium oxide.
The sound you're not hearing is the gears in everyone's head spinning. Because this is so new. It's like, huh, wow.
I put up my defensive wall right from the beginning, and the more I heard, the more I thought, yeah, I'm open-minded to this.
Yeah, there you go. And you've been making mirrors for how long?
Forever. Yeah.
Forever. Oh, all right. So that's several billion years right there.
Longer.
Well,
Okay.
if I could just add, even if it gets you 90% of the way there and it's not quite 100%, it still would be a major improvement to the process, because the pitch maintenance is high. The time to polish out large mirrors is long. And I believe Rob has experienced the same I have, which is pitch exhaustion. After a while, the pitch just loses its volatiles, gets so plugged up with cerium that you have to scrape off that top layer and kind of start over, which is, you know, a huge pain and setback. So if this can take us, it doesn't have to take us 100% of the way. If it takes us along for the ride for much of the part of polishing, you know, and pads, by the way, are not a panacea either. They tend to come off, and, you know, getting them to stick is a problem. So, you know, there is an area here for significant improvement.
Yeah, I think everyone over here agrees with that, Mel. Okay. Is there anything you'd like to add, Gavin?
I think that's it for now, at least. I'll continue to update when I have the time to start exploring more ideas with it. But yeah.
Okay, and thank you very much. I think this has probably been the most surprisingly thought-provoking presentation of the workshop so far.
Thanks.
So thank you so much. Okay, wow. Well, yeah, I think we're all in a little bit of our heads are spinning a little bit. And we are a little bit ahead of schedule, but not much. So next up is Rob Brown, and he's going to talk to us about his adventures in making a 16-inch meniscus mirror, which
We're gonna run it off your computer.
yep, no. No, same.
Hey, aren't we like really ahead? Because I gave my talk in the morning.
Yes.
Well, it's well, yeah, well, you're right. We have one less presentation for today, so we'll finish early.
Yeah.
But Rob and Gavin are on time,
Yes,
so
right.
Yeah.
But maybe we should email or something Alan Slisky so that he knows it might be sooner.
he sent me his presentation and it's narrated.
Oh. okay.
So
No problem.
that's nothing we need to worry about in terms of the schedule. So
There's a high probability I'm gonna go longer. So, don't worry.
Just
We
avoid
got
it.
the- Oh, no.
Oh,
well, Rob has sent me like 5 versions of his presentations,
come on.
maybe 6. And
Hey, this is fun.
oh,
Let's run the first one that he did.
oh, I didn't bring that up. Hold on. Hold the phone. Okay, I need to go to my desktop. I need to open up.
There we go.
Okay. Well, okay, come on, Zoom. Where'd you go?
Oh, yeah, there you go.
There we go. All right. Okay, so I'm going to share the screen so we have Rob's presentation. And I think we're looking good. You want to put this in
Full
Present-
screen mode and make that
presentation
bar go
mode.
away. Yeah.
get that to move out of the way. There we go. Come on. Come on, there we go.
Oh, God.
We will. We live on the edge here.
Okay.
All right, Rob.
So, Rob Brown here, and Mel gave an excellent segue when he said something about being crazy enough to do this. And as you can tell by my title slide, if that doesn't ring any movie bells for you, if you can see me on screen, you might notice that I'm carrying the rest of the costume with me. Happy Halloween.
Yeah. Yeah,
Because-
you're back from the future because this is all as 16, not 8.
Oh, that's right. Well, I never got that feedback from you. That was your,
I
that
just
was,
noticed.
ah. So
Oh, you're gonna whip me now.
Whip us into shape here.
if there's one thing I can whip into shape, it's this here whip, but I can't whip the glass into shape. So when you don't got anything, this is how you start, with a costume and a funny title slide. But I've got more than nothing. We'll get something for you here. So what I'm going to present to you is a combination of what not to do and hopefully what to do. But I've been at this particular mirror for 3 years, pretty much. Well, getting on 3 years. And I want to point out that I've had to restart from Sphere at least this many times. These are the ones that I could find record of, and I think that's all of them. The most recent being October 5th. And I'm happy to say, without stealing my own thunder, that I'm on a path that I believe will get me there. And I really thought I would make it, but no, I'm not there. You know, Mel will breathe on a piece of glass and whip it into shape, and I'm still polishing away. So I'm going to cover a few different topics before I get into the actual figuring stuff.
Daddy,
Oh boy.
how much do you think like a worker next door would spend on tools?
Yeah, I wonder how much a worker would spend on tools. Okay. So,
Very good. Yeah,
Anybody
double check
else?
to make sure.
yeah. Okay.
Okay, I think,
All right. Again, you guys out there in Zoom land, keep track of your mute buttons for us. So I'm going to talk about a few different general topics and get into figuring at the end. Talking about lap manufacturers here, I've had to rebuild my lap so many times that I wanted to put some smarts into it. I just have not had good luck with the idea of heating pitch and pouring it over a tool with a tape dam around it and getting it to cover uniformly at the right thickness and then channeling it and all that. And I finally threw it in my hands and I said, you know what? I got myself a 3D printer. I'm going to print myself some pitch cubes. So that's exactly what I did. And you can see here in white, I've got a 3D printed thing that's a mold for a silicone pitch mold. So I poured silicone adhesive or silicone rubber into this mold and then peeled that out. And then I went ahead and poured pitch into the silicone, which of course releases the pitch just beautifully because it's so flexible and non-sticky. And I was able to make these wonderful little pitch squares. They're 1 inch by 1 inch by 1/2 inch. And I just rest them down on a plaster tool that is pre-coated with a thin layer of pitch, pretty much from previous pitch lap builds. But if I were to start fresh, I would go ahead and melt pitch till it was just flowing like water almost, and then just paint that on the plaster tool and let it cool, and then you got something to stick your pitch to. When you do that, you just place your pitch cubes down in the geometry you want, and then start pressing your mirror. You don't need another heat gun treatment. They'll just stick to that tool. So that was a real saver, not so much of time, but effort and cleanup. And pitch, boy, I just, I hate it. My wife hates it 10 times more. So, yeah. So, one of the things I do with this silicone rubber mold is I get the pitch fairly fluid so that I can pour it in, and then I just use a metal paint scraper to just wipe across the top of that and get it to distribute out uniformly. And then I'm actually scraping liquid pitch off over the sides of it and onto wax paper or foil so I can put it back in the pitch pot. And then the goal here is, and that's what this lower right slide is about, is seeing how clean I get the rubber before that pitch is cooled down. And in fact, I've had to come back in with a heat gun and re-liquefy the top layer just to keep scraping and get that clean. And the reason why is that if you leave thin layer of pitch on your tool like that, that's just going to flake off. And that's really annoying because that gets everywhere. It almost goes airborne if stuff's so thin and light. So I try to get that rubber as clean as possible before ever breaking the pitch out of it, and that keeps things fairly clean. So, so that's just some notes on lap manufacture that I think is working well for me. It really takes a tip from the old days. Texero talks about pouring pitch into a beeswax lined wooden mold and then using a hot knife to cut it into cubes. And yeah, Dan.
Is that where you got the idea of 3D printing that, from the book of Texero?
Absolutely. Yeah, he said, if you can figure out a better way to make these things, go for it. It's right there in the text.
Rob Pierre here. By the way, you can buy these molds very easily on Amazon for about $8 or $10, and they're 1 inch by 1 inch by about 1/2 inch thick. they're used for making candies or whatever.
Yep. And I was aware of that. And the first thing that I made was not this. It was a very highly modified shaped kind of thing that I was chasing zones with. And you're going to see that later on. And that's why I did the 3D print, because I needed something really custom. So you're right. If you're just going to make cubes, then go buy one of these things, as an ice cube tray or whatever it is, Jello mold. But the 3D printing allows you to do things that you can't get off of eBay or Amazon. So let's see. Does it just click, or you gotta? There we go. All right. So in the vein of lap making, then, petals and spiders here. Going down this path so many times. Oh, a little bit of context. Long ago, in 1988, I spent a short stint at Celestron International, hand figuring secondary mirrors on 8-inch Schmidt Cassegrains. And that's where I learned about petal laps. Where I learned anything about polishing glass, actually. And we were just doing little 2-inch, secondaries, 2.5-inch secondaries, but we would use paper. We'd cut paper into little snowflake patterns and put them on a preheated lap. We used a little stove burner to heat the lap and try not to catch it on fire, and press the paper in and press the glass down into that. And we had a petal lap, right? And we could cut them in any shape we wanted, whatever the figure told us to do, we would cut them to that shape and figure, and that seemed to work. So I quickly got wrapped around the axle with petal laps on this project because I thought I knew something about how to make mirrors. Now I realize how little I know. So I'm here to tell you. So I made a petal lap, and I made another petal lap, and I made another petal lap, and then I did this thing with the cubes, and I just made a spider lap, really, which should have worked. It failed miserably for a bunch of other reasons. And then I ended up getting into this shape, which I used, this is 3D printed plastic also. It's thermoformed polyurethane that I printed out in these petals and then pressed those into the lap. Usually what I do is I put the lap in warm water and put these on and put the mirror on top, and then a few 100 pounds of weight, and just let it sit for a while, and then take it all out, and I've got a nice pattern pressed in there. Those pieces of plastic are 2 millimeters thick, which is plenty deep, and that'll last several hours of polishing. But you see, I did this shape where the petals, they don't taper out at the end. And so then I put in a taper, and that actually seemed to be working quite well, but I ended up with some roughness, which I attributed to there being just this one point of 100% contact at the center. So I then started adding more contact, and this is several iterations later. And I've got the contact up to about the 33% zone. And this is the lap that I currently have in my garage, and it is working. And you'll notice here in the zoomed in figure here that the tips of the petals stop at about 90%, and then they flare out again after that to take care of the kink that wants to form there and was forming there. So that seems to be working. Another thing that this first one didn't work very well was that the gap between the glass and the tool was 1/2 inch. And it's really hard to keep your glass wet with polish when there's that much gap. So I ended up actually putting some pieces of foam in there to keep the glass full of polish. And that kind of worked. What's that?
Your mirror.
Mirror on top. Yes. If you're doing tool on top, boy, you're golden here. But that's not the process I'm following. And I'll let Mel explain that one. But so I ended up, this tool, for example, has all of these tools beyond that. It's just 2 millimeters of air gap between the glass and the non-contacting pitch. So that's easier to fill with a foamy solution of polish. So, all right. So another one of my personal requirements here is that I'd be able to do this on a machine. It's just too much manual labor for me to push glass back and forth. And I had some tendonitis problems early in the pandemic that were not related to mirror making, but poor ergonomics at work. And I just don't want to go through that again. And, you know, the back's starting to hurt. I'm going to be 60 years old next month. And I'm just, no, if I can make a machine work, I'm going to make it work. So I keep coming back at it. I've had to use some hand figuring, some hand pushing now and then, but I keep coming back to the machine and going, okay, what is it that's going to make this work? So it's a modified Mirror-O-Matic. I got it from Tim here. Thank you, Tim. You delivered it to me in a state that it barely even worked, but by golly, it had a good motor. It had good bones, right? What it didn't have was good bearings. And so I ended up replacing all the bearings. I had to actually replace the shafts in order to put good bearings on the shafts. And but that thing just hums along now, and it can outpush me very easily. Whereas before, it could barely make the glass move across the glass. So that was huge getting through that. I made this this 8-legged pushing tool, another spider, and then my son, who's an artist, painted a spider on it for me. So thank you very much. And you'll see more of this later, but there's 4 nylon screws. There's a place for eight of them actually, and they go down through the wood and they contact the back of the glass and apply the weight of the polishing arm to the glass. And then out at the edge, there's like 3/8 of an inch diameter difference between the legs and the glass itself. So the glass has a lot of play in there. And key to this working and eliminating astigmatism before it ever starts is that play, those nylon bolts, and this piece of aluminum that comes down from the assembly here and engages with a pin in the tool. The tool does not rotate. The glass does, however. At the end of each stroke, that rotating lap grabs that glass and just indexes it about an inch or so. And I got this tip from Mel. He's saying, well, how much is your glass rotating in the tool? This was over a year ago. And I was like, well, I don't know. Is it supposed to do that? Well, yeah, it is. And I realized that fighting all this astigmatism stuff, gosh, if I just make the tool stop rotating and let the glass do, you know, get pushed by the pitch, this thing will index its way around. It takes about, I don't know, 50 or 60 strokes before it goes a full rotation of that glass. And in 10 minutes of polishing, that'll go around a few times. And I have had no astigmatism problems with this glass. And I was having them before when things were spinning around and free to move. So I proved that to myself, by the way, by thoroughly testing my mirror at spherical, because I could easily tell with a spherical mirror whether it was astigmatic or not. I could tell whether the test stand was inducing astigmatism, and by golly, it is. And in a previous presentation here, I talked about edge support versus center support. And when I get done with this thing, I want it to be center support. So those slings are bugaboos, and you'll see another slide on that later. Okay, did I cover the slide? I think I did. I just wanted to say, well, I got close. I got even closer with hand figuring, but it hurt. So, all right. Oh, here's the thing I did with the foam, and this was a good idea, but not a great idea. I actually took a paint roller and I just cut it in sections with my bandsaw. And once I got them down thin enough so they would fit between the tool and the glass with some room to spare, and just gently press into the foam roller or the fibers of the roller. Then I said, okay, let's do it. Hot glued them in place and loaded them up with polish. And it worked for a while, but then things started to go wrong. And sure enough, the mirror was starting to press down into the pitch more and more, putting more and more pressure on these pads. And then everything went out of balance and I had to take them off. And I was like, yeah, there's a better way of doing this. So that's why I now just have that 2 millimeter gap in the pitch. Here's another idea that I kind of think is in the spirit of our last speaker is like, well, I don't know, so I'm going to try it. And it's called a deflocculant. I know from working in ceramics what deflocculant means, and what it means, well, flocculate means that you have all these little particles in suspension, and due to electrostatic charges, they'll want to grab onto each other. And when they grab onto each other, they clump and they fall to the bottom. And you don't want that in your polish. So I looked up, well, what are some good deflocculants to use with cerium oxide? And the best thing I could find that was easily obtainable was good old sodium silicate, which they do use in ceramics for exactly this thing. And if you buy slip up from Georgie's up the street here, it'll have sodium silicate in it, and that slip will stay in suspension for a long time. You don't have to keep shaking it, right? So I did a little test. I made a solution of 15 milliliters by volume of cerium oxide to 400 milliliters water, 3 milliliters of dish soap, that's a teaspoon. And in one, I put in 15 milliliters of sodium silicate, and the other one, I just left cerium oxide and dish soap, and stirred them all up real good and looked at them 10 minutes later. And you can actually see the difference. There's a layer of precipitate down here at the bottom of this flask, and there isn't one here. The colors are different, and yeah, it's a whole different thing. And this is the same state. Just 10 minutes later, you can really see the sludge on the bottom of the untreated solution and no sludge on the stuff with the deflocculant. So very slick little tool. And I thought, well, okay, let's give it a try. I went and have been polishing with it now for over a month, and my mirror has actually gotten better than, because my cleanliness practices have gotten better. But there are now maybe 1 or 2 sleeks, and that's it. No more scratches, no nothing. Again, I attribute that to my cleanliness. This stuff is not hurting me. So, and it's, you know, it's forming a nice brown foam. And if the foam is brown, I know that there's cerium oxide in it, right? So, and it's figuring like crazy. I mean, yeah, it's making changes to the figure, so that's good. I thought, you know, a lot of people in this room probably know why we deepen the center when we parabolize, but I asked myself that question over and over again, because I also know that if I could just treat the 70% wave as 70% zone as good, then I'm only 7 waves away from the nearest parabola. So why do we deepen the center instead of treating the edge and the center equally at 7 waves versus 37? And you know what? I think I know the answer, but rather than answer it, I thought this is a good time for an open debate. So those who have opinions, speak up, and I want to hear what you have to say.
Well, from our Hartman point of view, we'd like to establish zone 7 as the datum, a free of astigmatism, perfect ridge from which everything else gets judged by. So we start shoving down the middle and leaving it as alone as possible. That's one reason.
Yeah, that's consistent with the left side here. Yep. Okay. What, another question is, why don't we do the other? Yeah.
So I tried the second way, Rob. Back on the first 13-inch F3 that I did, I systematically parabolized it 12 different ways to see which would be better. And the second way is one of them that I tried. So the problem that I could not solve is the steepness of the curve, generating that steepness and getting the curve of the right shape between the 70% and the edge zone. It either would be astonishingly flat or worse, horror of horrors, I would overbend it and get a TDE out of it. And you could almost look at the pitch lap calculator and see on the left side, those curves look a lot more gentle to deal with and to generate than what you have on the right-hand side, where you have that deep plunge down and deep plunge up. Now, of course, it's all relative, so you don't want to focus too much on that. But I couldn't control that. But, you know, it was very promising because I could generate parabolas pretty quickly. Now, there is a third way, which is to work from the edge inward, and I've tried that too. And I think that's actually more promising than either of these two. I tried it on a 20-inch a couple times. I ran into other problems, so I didn't pursue it further. But there's actually a whole range of possibilities in here, not just the two that you put up here, because maybe you could explain to people how the ROC matchup with the mirror can be adjusted so you can have any range of these curves as you feel you can deal with.
That's right. There's literally an infinite number of solutions to the parabola that you're going to get when you start from a sphere. And if there wasn't, by the way, then none of us would have ever produced a successful mirror. If there was only one solution, we'd never get there.
One thing about
yeah.
your second method is if you go to figure XP and you shape it like a hill, you look at cubic millimeters of glass to remove.
Yeah.
And you shape it like the other one, you look at cubic millimeters of glass to remove. That guy has 4 times as many cubic millimeters of glass to remove as that guy does.
Yeah.
So you've got your wave model here, but it's a volume model.
Absolutely, it's a volume
It's a
model,
huge volume.
which really compels me to want to try the thing on the right. But what Mel said, and I kind of knew you would, and I'm actually firmly in Mel's camp, that I would much rather deepen the center than try to attack the center zone and the edge zone, because the steepness of that curve, and I wasn't thinking steepness of the curve, but that's what Mel just said. It's so steep that trying to control it is going to be hard. In my practical experience, as soon as I got a lap that's any more complicated than the one on the left, I run into trouble with kinks and other zones and all sorts of nastiness that I cannot get control over. Now, I'm not Mel. I'm not Baldy here. But you know, the thing on the right was exactly the kind of thing I was doing at Celestron. And it worked, but they weren't thin meniscus lenses. They were 2.5-inch diameter thick.
So were they a convex hyperboloidal? secondary?
Convex
Isn't
hyperboloidal.
the wear way kind of backwards from the concave mirror?
Well, yeah, and all that, sure. Yeah. And I don't know, you know, this is so long ago, I couldn't really tell you how Celestron came up with this idea of doing it this way, but once we learned how to read in a double pass autocollimator where the high spots were, we knew exactly how to cut that lap to hit the high spots. And whether they were actually high spots or actually low spots, I couldn't tell you because they're backwards from a normal mirror. And it's so long ago. But,
So Rob,
anyway,
could I add one more comment?
sure.
So there's at least 2 regimes that you could think of. For quite a while, I would beat myself up because mirrors would start so promisingly. And I would get 10% parabolized, perfect control. And I would think, oh, wow, if this were a 30-inch f8 and I could go up 2 or 3 stories, I'm done. This is great. 20% parabolization, pretty good. 30%, pretty good. 40%, what the heck is going on here? Kinks and all this stuff would suddenly form. And what's really happening is that the slope now is becoming so steep, is getting really difficult to control. And you can think of lots of analogies, trying to drive a car on a steeply, sloped road, or the wind, you're always trying to turn the wheel in and the car is always shifting a couple of inches. So, when you first start, even the model on the left, you go, oh, this is easy, what's wrong with these people? And then you get around 40, 50, 60% parabolization and you go, well, I guess I'm stuck too. So the steepness here really plays into how these models work out. The one on the right, if you're doing an 8-inch f7, it could be great.
I absolutely agree. And you're actually touching on slides to come here, because I've been just where you've talked about so many times. And it's like, okay, this is working, and then it's not working anymore. And oh, crud, what do I do? Back to Sphere. Hopefully those days are behind me. But yeah, I think on an F6, 8-inch F6, well, shoot, why not try the 7-wave approach? Well, it wouldn't be 7 waves anymore on an 8-inch F6. It would be much closer to parabolic to begin with. Yeah. So in the context of a 16-inch F3, by golly, I'm sticking with deepening the center, at least for now, until I get a mirror out, and then I can talk about other ways to do it.
Just one comment.
Yep.
With the mirror on the bottom, I find that you really expect a perfect sphere off of your polish. And you expect a perfect edge, or at least close to it, off of polish. So the more you work that edge, the more you lose that, especially when you go to parabolizing with a 60% tool.
Yeah.
And so your chances of, when you slow the RPM down and you're parabolizing, you have a really good chance of messing up the edge. And it gets really a lot more difficult out there to produce those outer zones. So that's a real big advantage to the number your left side there, that kind of leave it alone as much as you can, get it done early with the spherical work, and then maintain that through the rest of your figuring by deepening the center.
Yep.
Yeah.
Mirror on top, tool on top share that same philosophy.
In all
Yep.
fairness, we're tool on top, we're sub-diamond tools. This is an entirely different process. I don't even think I got the right to comment on anything here. It's so different.
Yeah.
You guys have like a big lap and your mirrors on top. I don't even know how to approach parabola.
Yeah, well, we'll talk later. Okay, thank you, everybody. I want to move on. Another slide of interest here is there's been a lot of discussion about astigmatism lately, and I thought I would just put this in here. A couple of weeks ago, my mirror was in a state, and it wasn't anywhere near parabolic yet, but I thought, well, I got it sitting on the stand. There's no astigmatism. Why don't I just run this thing through focus? So I've got outside of focus on the left, at focus somewhere in the middle, and inside of focus on the right. And you can see that these shadows are very symmetrical and, kind of a straight line through the middle like you want. And then I went over to the test stand, and all I did was I grabbed that sling and just moved it a millimeter. And that's what it did. Now, this is a thin meniscus. It's not a big, thick piece of glass. And I don't know the magnitude of this astigmatism, but boy, you can see it. So if there's any debate out there about what it is you're looking for with a Ronchi grading in a test stand, I hope this answers it. This is gross astigmatism, of course. But if you see this, go fix your stand if you got a meniscus mirror, because you should be seeing what's up on top. And if you can never see what's up on top, no matter your orientation, then question the glass. But make sure your stand is good first. And my tip from my last talk a couple of years ago was build your mirror mount and use that as your test stand, because that's what your mirror is going to be in, right? So I built my mirror mount and I tested it at spherical so I could really pick up the errors and test my test stand and test my mirror mount. And I feel very good about my mirror mount because of that. So, okay, moving on. So now I'm getting to the point of where I made a breakthrough, and I have some things to share with you that are going to be a combination of do this and don't do this. And the first breakthrough was putting enough weight on top of the quill on this machine. And I wish Chris were online. Does he live in France, Chris? Boilot, is it? How do you pronounce it? Boilot? Yeah, anyway.
He's in Belarus.
Belarus. Oh my
Yes.
gosh. Okay.
Oh,
That Chris. Yeah. Well, Chris, I hope you're listening.
Tanya and Chris Boylan.
Yeah. Tanya and Chris. Chris, when you listen to this online, I want to just thank you for the tip. Because I know I got it from you about putting enough weight on. And when I started adding weight, I started seeing the thing I wanted to see, which was the center getting deeper. I went through month after month after month of Mel telling me, get the center down. Yeah, Mel, how do I get the center down? And nothing I was trying was working. And I think neither of us understood what I was doing with the weight on the top. And So when I was having, I was using 10, 15 pounds at most, and I found if I went to higher amounts of weight, then the mirror would just stick to the tool. And then Mel taught me about soap, dish soap. Now I'd been putting like a drop or two of dish soap in my 400 milliliter bottle, but that's not enough. Not for me anyway. So I went up to, a good teaspoonful, 3 milliliters. And now when I shake it up, boy, it forms a foam, and it forms a foam on the lap. And, it's no kidding, it's soapy solution, but that enabled the weight to go up. And so when I was ready to try increasing the weight, I was still able to polish. Oh, okay. So then we're going to talk about weight distribution. And here's a great cross section showing the nylon bolts coming through the tool. And then I had here a yoga mat. This is like a 4 millimeter thick piece of foam, right? And I cut out a small disc of it, about 6 inches in diameter. And I set my screws such that they were just barely touching the glass when this was loaded up with the full 16 kilograms, 35 pounds. So that I knew I was putting all the weight in the center of the mirror. And that's what happened. I went from barely making a nudge to, oh yeah, there's a good change, right? And that now set me on a path. It turns out that I needed to remove that foam at a certain time, and that's keeping me on a path to success. So the foam isn't staying. I've distributed the weight out to the 40% zone and later again to the 55% zone, as I'll show you shortly here. So spreading it to the edge, dig the hole, spread to edge. I've heard this so many times. These are pairs of ronchograms, outside focus and inside focus. And you can just see the center deepening and starting to spread out. And I used some longer strokes and some shorter strokes, and on it went. And this is now 2.5 hours into parabolizing, which is just agonizingly slow, but that's my patience level. It's not very good. So at some point, then I realized that to get more to happen, I needed to taper the tips of the lap. And so I did that. And although the pitch lap calculator doesn't predict a huge change in performance, there's enough there to say, well, it's something. So I did it. And then you could see that center hole start blending out toward the edge more. So this is another hour later. And at some point here, where did I do it? Let me take my glasses off. Or at one point I moved the, oh yeah, okay. In the second, whoops, page up. In the second figure, I had removed the center contact, and now it was all out on the 40% zone, and again here. And this got me really excited once I started to see that. And that was just a few weeks ago. Okay. I started noticing this roughness, as I mentioned earlier, and the lap was getting very sticky near the center. The glass was just sticking to that center point. So I started spreading the pitch out, and you can see the results of that right here. The new lap has a small amount of center contact. I hope I'm not messing anything up. And things started to get more and more curved, and this is getting really exciting. And I just kept going, and it's like, okay, things are starting to hook over. It's looking a little flatter in the center. And then I said, oh, I think that's when I need to deal with that kink. And that's when I put in that zero contact at, actually this is at 78%, and that did something. I can start to see this S curve happen again. And that got me very worried, because I've seen this shape in my mirrors every time. And in the past, this was the death of me, because I was thinking I need to push this thing here down, this hump right here. I need to push that down. And that's technically correct. You can see how you'd want to do that, but it's not really what you're going to do with your lap. Instead, you're going to treat this whole thing as digging out the center and blending it out toward the edge. not attacking it directly. And let me see if I can illustrate now. So, what do I got on the top? Oh, so I said I tried to dig the center and I overly succeeded. I moved the weight from the center to the 40% zone, and I kept going for a while, and then it just stopped and it didn't get any better. So then I put the weight out at the 55% point, and you can see right here how I moved from a screw position. Boy, it's hard for me to even see right now, but there's a 40. Oh, there's a hole right there at the 40% zone, and then there's a screw at the 55% zone. There's another hole right there at the 40% zone. And just redistributing that weight smooth things out, but I'm still thinking of, I'm deepening the center, I'm just redistributing the weight, and things are starting to smooth out. This got very exciting. I even put down here something about Mel is always right. I just don't always understand. I'm sorry, Mel. Likewise, I can't say that I'm always clearly explaining myself to Mel. And it's clear that sometimes we take a couple iterations before it's like, oh, yeah, that's what you mean. Or that's, you know, we're both probably saying that. So, yeah, okay. So then what did I do? I freshened the lap. I moved the edge, I moved that kink out to the 90% zone, and I continued on. And boy, this is a thing I've never seen before in my mirror making on this mirror, where it's now looking more like a smooth curve. Yeah, it's hooking pretty steeply here, but it's not a kink. It's not a big old fold, you know, it's just curving real fast. What do I got to do? I got to deepen the center. I got to deepen the center. I got to keep that edge where it is, like you were saying, Baldy. It's done there out at the edge, and it's probably not done that, but you know, it's closer to done than not. And I'm going to deepen the center. So it turns out that I thought I was going to end on this slide, but this was Thursday night. I did some more, and I kept going, and the center got a little bit flatter, which depressed me. But then I saw that the correction was still going in the right direction. So it was like, okay, what do I do? If the center's getting a little flat, I think my next step is to move my contact points in closer, because they're out there at that 55% zone right now. So that's probably the teeter-totter I'm going to balance, is where do I put my contact points on those nylon screws? And Mel did exactly that on his 16 with his hands. He said, you know, if I want to hit a high spot, I put my hands there. And that's where he's pushing down on the lap. Well, don't arm wrestle Mel. So, okay. So a couple of tips about the Ronchi matching test. This has been just wonderful to watch this evolve over the past year or so as Mel has made changes to it. And so incredibly powerful, but like all power, you got to be careful how you use it. And just as recently as last night, I got myself very confused. I saw Mel do something in his presentation yesterday morning, and I was like, oh, I can't wait to go home and try that, update my last slide and see what I get. And the very first thing I noticed was that way up high in the tool, it tells you what correction factor you want to work with. Parabolic is 1, less than parabolic is less than 1, right? So I put 1 in there, and I got these looping bands, and then I had to figure out, okay, what am I going to do with that? And I said, well, okay, I'll try 0.5. I was at 0.36 earlier, and 0.5 seemed to be a very good fit. I said, great. I came down to the next thing, is where you start treating the zones, and they all said 1 right here. Okay. And I was like, well, I can start modifying off of 1, or I can use that button that says use parabolic correction. So I clicked on that button, and these all became 0.5. I was like, great. But it changed the match. And I started correcting them, and I realized, oh, that's no, that's wrong. If you use that button that says use parabolic corrections. It'll set them to whatever you want, but then you have to go back up and put 1 in the initial box so that you have the right thing you're correcting against. So I have a parabolic correction of 1, but all the zones are modified down to 0.5 with a few exceptions. And that now gives me an accurate picture of where I am in the figuring process, which is still 7 waves. And my last note down here is I'm overanalyzing it at this stage. And this has been my personal challenge, is overanalyzing. I'm an engineer, so what am I going to do?
Right.
Yeah, exactly. So so that's where I start, you know, in previous attempts, this is where I started really forming exotic petals and doing all sorts of stupid things and not understanding what it was that I needed to be doing. And Mel told me, and he was right. Mel told me, you got to deepen the center, get the center down, keep working the center. And I'm like, yeah, but I have all this kinky stuff going out on the, 50% zone. And yeah, that's what I needed to be doing. So the whole purpose of me doing any zonal correction at this 50% parabolized state is solely to stay sharp with the tool, but not let it influence my next move so much. Because I know now what I need to do. And this isn't going to tell me so much because it's deep in the center, dum-dum. So, okay, I'll keep doing that. But in deepening the center, of course, I got to be careful about walking that tightrope of where the weight goes. And that I think is going to take me quite far. So, okay. Now we get to the point where I've got 3 things. This is the first, where Rob went wrong. And I've told you many times that I've been in this state before where I've either got kinks or I've got humps or I've got other ugly things. And it caused me to do some really radical stuff. Here's that lap that I mentioned. This is the reason why I 3D printed a silicone mold, is so I could make this exotic shape. And boy, that didn't work. What's wrong with this picture, Mr. Brown? It looked like the thing I would have been doing at Celestron, but it's not the same beast, that's for sure. Interestingly enough, going back, and some of these go back a couple of years, going back and digging these out to put this in the presentation, I look at them and I'm like, oh my gosh, these all seem fixable with the things that I'm doing today. None of these would scare me anymore like they were before. They wouldn't cause me to make a radical lap. They would say, oh yeah, just keep using your pedal lap and put your weight there and use the right amount of soap and, just keep plugging along. It'll smooth out. So, yeah.
I just wondered if that was a halo or a hat.
Take it any way you want. It's in one case, it's covering the horns. So yeah, where Rob went wrong, but where Rob went wrong isn't the end of the story. Oh no, there's Rob's outrageous wrecks. And most of you know that on July 4th, 2021, I had a mirror that was ready for star testing and it dumped out of the fixture and onto the pavement because I didn't know what I was doing when it came to mirror support. Duh. I mean, such a bonehead move. In my excitement to get a mirror tested, I forgot all the things I should have been doing to keep the mirror safe. So come on. I mean, that was like, I felt like a 10-year-old, getting into his parents' stuff and he shouldn't have, it was like, you idiot. So, but it didn't stop there. No, because on May 14th, 2022, I dumped a second mirror on the pavement and this one was pushed off of the polishing machine because I wasn't attending to it. And boy, and it's exactly why I bought 2 when we placed an order for 3. Mel got 1. I got 2 because I'm not Mel. Okay. And I'm so glad I did. I thought I had dreams of making a binocular, but I knew that really what I was doing was protecting myself. Now it's like, oh geez. So I sit there at the polishing machine in my little chair, and I'm within, sometimes I've got my hand on the switch. And I'm just, if I'm not reading a book, I've got my hand on the switch and I'm watching and listening. And sometimes now I can read a book and I can kind of keep it in my peripheral. And as soon as I hear something that didn't sound like the stroke before it, I'm up and looking and ready to hit that switch. And I've caught it a few times where the tool that's grabbing the glass jumps off the glass. I've caught that a few times. And, I've realized that when that happens, the mirror is stuck to the pitch so firmly that the machine is just, pushing it right off of itself. And I've actually got a couple of strokes of tolerance before anything bad happens. So I've got plenty of time to shut it down. But, the heart is in the throat and the pulse is going and the machine gets turned off immediately. And then I need to put some more polish back on that thing and keep going. So, all right. Plaster spills from not using gaff tape as the mold. Well, I'm not pouring pitch into a mold anymore unless it's a silicone mold. But for those of you who are still doing that, or you got a plaster tool and you wrap tape around the edge of it and you're going to pour your pitch in, nothing like gaff tape. Even the best masking tape I was using was just breaking free at some point and the pitch was pouring out and onto the garage floor and not fun at all. Being a mirror on top person hasn't limited me to mirror on top. I've tried tool on top. In fact, I found tool on top is the best way for me to get back to spherical, knowing that I'm going to have to push out a very badly kinked turned edge in the process. So full contact lap. I've got my mirror in a plaster mold, fully supported by foam on the turntable, face up, and then the full size lap on top of that with my grabbing tool and pushing the lap back and forth. And I'm able to get back to sphere fairly quickly, a couple hours. But I let that go one time and the quill popped out of the tool, pushed the tool off onto the floor. Of course, the tool didn't break, but the darn quill was running across the surface of the mirror for I don't know how long, and I had this wonderful spirograph scratch pattern in it. That I'm very happy to say is no more. Not because I was determined to polish it out, no, but because I'm determined to get my mirror figured. God.
Those are pretty spirograph patterns.
They are pretty, yeah, until they're in your glass, boy.
So should we consider like an inch worth of foam on the concrete floor around the machine?
Absolutely, yeah.
Might get
I'd
1
say
ounce of it.
I'd say 6 inches of foam, yeah, for sure. Anyway, okay. All right. And well, that about wraps it up for Rob. Any questions?
I have a story.
Yes.
I tried to make 2 lightweight mirrors in my career. I broke them both.
You did? Well, congratulations.
Well, I blow up FETs now from time to time. But,
Yeah, FETs, sure. Those things are filled with smoke, aren't they?
yeah,
You let it out and they don't work anymore. I know. Yeah. Okay.
How do you use masking tape for the dam for your pitch?
I don't.
Well, how did you?
Well, how do you just put the tape on and it just didn't stick.
Put it sticky side out on the first layer,
Oh,
sticky side in on the second layer. It seems to look pretty well. 2 layers.
Strengthen it too.
how do you get your tape to stick to the plaster?
You'll get enough overhang on the second layer that it'll stick.
No, see, that's the problem is if I use even full contact masking tape on the edge of my tool, it wasn't sticking enough.
It's gotta be dry.
Oh, yeah. Oh, dry. Yeah. But I tell you, it's been more than once. I've had pitch drip out from cracks or gaps, whatever. And it's not worth it to me anymore. So I've gone to this silicone mold for my pitch.
I like that.
Yeah.
now your lap is larger than your mirror.
No,
It is, okay.
No.
I was under the impression that Mel or somebody was doing a lap that was larger than the mirror, and I've never known how that's done.
Mel, how do you do a lap that's larger than your mirror?
Hi, this is Mel. Just like any other lap, I don't understand the conundrum here.
I think the conundrum that I would have is when I were to press my mirror into that pitch, I would leave a raised edge all the way around. So what do you do?
Well, pressing a mirror is a bad idea all around. Don't do it.
Wow, it's quiet.
Yeah,
Pressing or cracking?
pressing the mirror. How do you keep your mirror in contact? Let's say you're just building your lap and you've got this horrible shape and you need to get it in contact with the glass. What is the first thing that you do if it's oversized?
Just like I would do any other lap, I put the mirror on the lap. You're surely not going to leave it there for very long because you can create a vacuum or the pitch might begin sticking to the mirror in the spot where the water vaporizes. You're gonna pick it up, move it around. I advocate picking it up and dropping it back down a little bit over. Because if you push on it, what you can do is create a dam of pitch that you begin to push off the edge of the lap. It's better to pick the mirror up and put it down. But how many of us can really put the mirror exactly on top of a 100% pitch lap? Anyhow, when you move your fingers around the mirror and you think it's on there, you can see that, oh no, it's a 1/16 of an inch off or something. So
I see what you're saying. So
yeah,
the
so
fact
really,
yeah.
I know I'm being a little provocative in saying just treat it like you would any other mirror, and which is don't press, put it on, move it around, pick it up, put it back down. But yeah, so the easiest way to get into this is just create a full-size pitch lap and use it. After a while, the pitch will begin to push out from the edge and it will have the mirror shape to it because it has to, because you're moving the mirror back and forth on the lap. So when the lap gets to be 1/8 of an inch oversized or something, that's great. 1/4 inch is no different. I think it gets a lot harder if you're making a, Brashear used to advocate a 6:5 oversized lap to really control the edge. This is back in the 1890s, and that will work. But that's best for smaller mirrors. On larger mirrors, it can get a little overwhelming to do that. So yeah, I hope that answers questions.
Yeah, I think so, Mel. I guess the short answer is to get your lap initially in contact, you have to think of it as pressing the mirror everywhere all at once. So you're going to move the mirror around, press a little bit, move, press, and just work your way around that lap until it's all pressed out, right?
Well, actually, what I do is the pitch is soft enough. I put the mirror on there, I pick it up, I move the mirror, into the third portion of the lap, pick it up, move it to the other portion of the mirror. Then I pick up the mirror and I set it aside and I spray some cold water on the lap because I want to freeze it now, so to speak, get it to cool down, get the mirror to cool down. I wait a couple minutes, I put the mirror back on, I pick it up, put it on, pick it up, put it on, go through that a couple, 3-4 times, pick up the mirror, set it aside for a few minutes. And, within 10 minutes, you got a really nice pressed lap, exactly the shape, cool down, ready to go.
Another hint there was that your pitch starts off, it's still very, very soft. And the pressing is no more than the weight of the glass itself. So you're not pressing, but the glass is bearing down on the pitch with its own weight.
That's right. And that's what, when I'm kind of being facetious and saying, don't press, you don't have to sit there with 50 pounds of cold weight overnight. You don't have to do that to press a mirror. In any event, as soon as you start polishing, if you're doing it halfway effectively, pull the mirror off, put your hand in the middle of the mirror, feel how warm it is. Now put your hand immediately to the edge of the mirror, feel how cold that is. So there's big temperature variations in large mirrors anyhow. So, you're really just trying to get the pitch to conform to the shape of the mirror. And you can do that with these quick, put the mirror on the lap, pick it up, put the mirror on the lap, pick it off in a few minutes and be ready to go.
Got it. I'll add sort of a tangent thing to that, which is I found in this last run, in fact, actually the last couple of months, really, that since I've gone to the 1/2 inch thick pitch and let it compress no more than 1/4 of an inch from there, I have not had trouble with maintaining contact. And you know, I used to have either the center would lose contact or the edge would lose contact or something like that. And those days seem to be behind me for some reason. That's a good thing, especially if I had an oversized lap. Then I'm not having to worry about pressing out, you know, keeping contact on a larger lap. Because I don't know what I would do if I lost contact on a large size lap. Because now I gotta press, or I gotta heat up the lap and start over again. I don't know.
I think on the oversized lap, as soon as you get it kind of pressed the first time and pulled the first time.
Yeah,
Got an unpolished mirror and a new lap,
yeah.
and I think you put it on your machine and run it from there until it's polished,
Well, figuring is what I'm talking about.
but you don't figure the. As far as
Oh. Okay.
that's as far as I know, I've only heard about an oversized lap for figuring, getting to a sphere with a good edge.
Oh, I see.
I'm really experienced when it comes to that. I've tried it.
That makes
I looked at it
sense.
Pretty hard back when it was.
Yeah,
popular.
that makes sense. Yeah, yeah.
So let's, tool on top, guys. We have our ground mirror, put a sheet of garbage plastic liner on there. Put a lap mat on there. Pour the pitch and lap mat, place the aluminum tool on there. When it cools off, peel it off. Done. No pressing. And so that's why I'm having a hard time saying, well, what if the pitch is actually bigger than the mirror?
Yeah, you're stuck in that case.
So it's just a little unusual for me. I'd like to see it done sometime.
Come over to my place.
So,
All right, yep,
so you're doing this in your garage
yeah,
and it's not temperature controlled.
No.
Have you seen the temperature changes from day to night, from season to season, to have any impact on what you're doing?
well, I can certainly say that in the heat of summer, if I have to do any lap pressing, it goes faster. And conversely, the lap gets thin a lot faster, and then I have to redo it. Generally, my garage hovers around 75 to 80 in the summer. Sometimes if it gets above 80, then I just don't even work. Right now it's right around 60, 65, and it's going to be hovering around 55 in January. And I don't know, I really want to get this done like now. But if I'm working this thing in January, I don't know what it's going to behave like. I don't really know what the colder, harder pitch is going to do to me.
Or would you switch to a softer pitch?
I can't, I got Google's 55.
Oh,
Yeah,
that's fairly soft.
that's right. So I wish I had a temperature controlled workshop like some of us do, but no. That said, you know, I think that I certainly have worked mirrors in the winter, or this mirror in the winter, and it seemed to do what I wanted it to do until it didn't anymore. But you know, everything was going wrong back then. So
You put untold hours,
untold.
a lot of determination, persistence, and you have been undeterred. You have not given up in where many people would have given the exact same circumstances. You must have a name for this mirror, whether it's profane or not.
I do. I have a name for this mirror, and I'm going to get out of presentation mode so that I can properly share my name for this with everybody.
If you want to stop here, it's up at the top. Just to the
Am I
right.
still sharing? I want to be sure I'm sharing. Yeah. What I want to do is get a nice big font here, and I'm going to type the name. And there should be an umlaut over the O.
It's good.
Very nice.
That's my working name for this telescope.
Okay. I like it.
Rob,
Okay.
in case you're feeling bad, a few months ago, I broke my 40 inch.
Okay.
Nice.
So, don't feel too bad.
Yeah.
Finished 8-inch lens. Oh.
Oh,
I-
yeah.
I saved that
Oh,
biggest piece, which was that big,
1-inch piece.
and I was always gonna make it into a trophy for the club.
Nice.
And,
Yeah,
lots
yeah,
of
yeah.
Different mirror makers, but
Yeah.
there have been so few in the
Maybe a
club.
booby prize trophy.
Yeah, I think Rob probably do that. Yeah.
No, no, thank you. I do not want your stupid little piece of broken glass. All right. Thank you guys very much. I'll get out of your way.
So Rob, can I add one more comment? So listening to you just makes me twinge because it brings back all these memories of difficulties and pains and lack of patience and everything. But I tell you, the best anesthesia is that first look through the eyepiece after it's been silvered or aluminized, and then you forget all the pain.
Very good, Rob.
Oh, my goodness.
You have a break.
Speaking of breaks.
Yeah, let's take a 10-minute break. And we'll come back and we'll wrap this baby up. I'm just going to put this on pause for recording. So remember, 10 minutes will go by like 2 minutes. We'll feel like it goes by. So don't go too far.
Hey, could you say on there that we changed the the edge, so all the Zoomers.
Yeah. Yeah, just as a reminder, Dan's saying, you know, we had to reshuffle the schedule this morning, so the rest of the schedule's been out of whack. So when we come back, we're going to have one more presentation and then my final remarks.
Say that I gave mine in the morning. You
Yeah.
can get it online.
Right, and Dan did his first thing at 9:30 this morning, and then Russ did his just before lunch. So there we go. All right, so you got 9 minutes now.
So with Mel.
Everything has been recorded successfully, right? Fingers crossed.
Yeah.
Well, I'm pretty sure Monday morning was not recorded on YouTube, but it was recorded on Zoom.
Yeah, okay.
But that shouldn't be any problem to transfer into YouTube's.
Yeah, that makes sense.
Yeah,
Thanks, Howard.
you're welcome.
That helped me understand it.
We manage this weight imbalance. We have a whole lot of weights.
That's a lot of offsets.
Yeah, oh, I know that. Yeah, yeah, yeah. And
Yeah, sorry,
we don't have we have number laps on that side, but everything is big color. And the length of the stroke. We don't have I'm tending to go center and not do offset.
So with you pedaling, you're not straight, you're sloping. And sometimes focusing and sometimes up.
Never offset.
No, not even.
Well, if it is, I don't know about it.
It's not intentional. That's right. We, when we do, like a smoother stroke, or we're doing a sequence, we're half inch off center and inch off center. Inch and half inch. His setting is a little different than mine. I
looked at, Carl's on Google's instructions, and it's very much that. You go through this routine of length, offset, and yeah, and it's very, yeah.
It really does.
It keeps it smooth.
A million things you do before you finish.
Right, and I thought about following that, and I was like, you know, I'm better off with now, doing the things that he's teaching me. Yeah.
What's your experience with the plaster mold? You talked about doing the tool on top of the full-size tool like you're doing,
Yeah.
upside down in the meniscus. How did you support it on the turn signal?
Well, that,
You made
again, I had
plaster
that
mold
plaster
underneath?
mold on the backside of the,
Correct.
I already had that.
That would be under the curve. Your mirror be, okay,
We talk about meniscus support.
yeah,
Yeah, so I got a tool that matches the back of the move.
right.
So the glass sits in that form on a piece of thin yoga mat.
That was my question.
Yeah,
Did you
yeah.
put a little bit of rubber in there?
Yeah, exactly.
You probably had to cut it, there were a bunch of us that went around.
It's one big yoga mat, and then, you know, I'll polish it and rotate the glass in the tool. And then polish it more and rotate the glass. Just keep doing that. I'm not generating any of this. Doing that. So, yeah.
Last time, they cast into the back of the mirror, everything like cast. It will spin the two together. Make the circle.
That's
Then we flip
exactly.
the thing over and we mill the other side so that it's flat and can't wobble on the turns.
Yeah, I see. And so with the meniscus, I have two threads. So it's gonna go through.
Yeah, so let's see, right now we're at
It's
3:30.
tool.
So
Take the back. one,
the last presentation is
and then a
about
jig,
40
you run the
minutes.
router like that, so it makes it flat with respect to the front.
Question and answers.
Yes.
Let's say 55
And when it
minutes.
goes on the table,
My comments will probably take about,
Yeah. And so that's
Five.
another thing, is like my table isn't like
So-
that. My tool isn't like that.
so
I did
you
take
should,
the tool on top.
before
rear facing
five.
up.
Yeah,
It
sounds
it
good.
was wobbling, a good, that much wobble in it. I was like, well,
There's your signature.
I said, if this, I'm gonna be diligent about turning that thing into tool. And I was, and I said, if it causes any astigmatism, I'm gonna get it out of there because I know how, I've been there. But it
My
didn't.
theory is if you have no wobble, and if it's perfectly eccentric, you don't have to rotate on it.
I agree, I
Yeah,
agree.
so.
So I was just like, well, I know people do that and I better do it. And it
Well, I
worked.
love hearing about you upside down guys. I'm not ready, I'm not trying.
You upside down guys.
No.
I'm not ready to
He's
try
upside
it,
down.
but it's fascinating to me because like. It's wrong, it's like, how are you doing the same thing we're doing, only upside down?
Texero describes it both ways.
Yeah.
And took many a look at Texero in thinking about how I was gonna attack some of these problems. And honestly, there are times when it helped me and times when it went absolutely contradictory.
This is confusing to me about. You are making the center of the mirror more complicated.
Oh,
You raise a big ass.
Oh, right, okay. I thought it was.
Have that screw around
But
the
it
mirror.
was, you saw the spider, you saw the spider. cave, well, it's the technology one. It's almost like a mountain. I mean, the really is greater in the center because you have more contact in the center. The area of contact.
Don't know what
Higher in the center. Equal stroking, it all averages out. You got more wear in the center than you do on the edge.
And if you think about a disc, they're sliding back and forth. It is really nice. Yeah. Center of the top. There's no backlash.
So I don't know if I can make it center, we're upside down.
I don't know. You're making something, we're upside down. now.
Flip it over. Of this size. Parabolizing in a full size lap? Used. Of course not. Correct. Where you can control the amount of air. You would buy when you spend.
Totally good deals.
It's not much. It's different orientation.
You know about this far away. Sure, you don't want that. About this far away.
Well, who's gonna suffer you?
Only me.
Yeah. I would,
That's one story about mirrors going on the floor, reinforced in my thoughts, the mirror being on top and the spider control.
I'd rather have the tool get pitched in the glass. Yeah.
I used sub diameter on the one, and I had some mirror, the tools probably.
Well, we got a really good way of monitoring and checking the thing, because we don't have a.
This is my first take.
Really should get it.
Well, it's a constant. So 3/4 of the new.
And who made that?
Newport. Yeah, well, it was supposed to show up and it didn't show up and it didn't show up. And I called them a couple of times and it didn't show up and I called them again. And said, it'll be done. And it was.
Where'd that bullwhip go?
I put it with
Oh,
your
thank you.
kept over there, so you wouldn't forget it.
Indiana Jones here, yeah.
Ledge,
That's so,
pretty much straight line and flat on the back.
when you crack the whip,
Yeah.
first
And it's
thing that
straight,
came in my mind,
straight.
you probably
Radius.
do that while riding the unicycle.
I'm not sure what they did.
No,
Because you can see the ground.
No, but,
Okay.
no, but,
you can.
sure, yeah.
I believe it.
I of course learned this from
I
that
sued
community.
it once.
This was made by a local
And now you
gentleman
won't even
who
sell it.
got into whip making, and you see how that the tapers like
Yeah.
that, right? Feel this right here, how inflexible it is. It's actually got,
I've
bead
I've got
chain
several
running
pieces.
down it at different lengths, and the bead chain probably stops around right here, so.
Okay, and then this is
So
just,
there's a lot of
But,
mass right
but
here,
I'm
and there
sure-
ain't so much
I'm
mass
sure what
way
they-
down here.
It's what they had was a
What
3-inch.
The whip crack is this thing breaking the space in.
Yeah, stick.
And the way that happens is by transferring the momentum
The grinder and.
in this part of the whip. And what
I
you
don't
don't really
care.
see is that this thing kind of
Because
curls up,
I
and then
essentially have a
you throw that curl.
Probably.
And as the curl moves, the mass drops and the speed increases.
Yeah,
And
exactly.
wham, out again.
And it's perforated already up to within.
All plated and
Oh,
screwed.
yeah,
Well, it's like fly
How
fishing.
about that?
One
Yeah.
minute, because you fly.
Where I got the weight on.
Well, yeah, fly fishing uses that same kind of leverage.
It is.
that you want to
On
control.
the backside.
Does it?
On the front.
Yeah.
So I filled it,
We'll
while I'm
go
working on it,
faster
then I'm
than
gonna take
finish down
the
the
brass and make it.
Yeah,
it's a rounded cone and-
At least the feathers are come off, yeah.
You can do it. And then you spot where you want.
That was a whole nother level.
Special aid skill.
Jordan, Mary told me, I might actually.
Okay, we got about a minute.
Tell me, does John Briggs look a lot like Dave Davis to you?
I thought that's who it was at first, yeah.
Looks
We
like
could be
brothers.
brothers, yeah.
Oh, thank you.
Very, very much so.
I keep looking at them going, oh, Dave's on.
Yeah,
Dave.
yeah.
Look at that.
Okay.
Good job. Rob, that was a really good learning experience. Thank you.
You whipped us into shape.
Yeah.
Did we provide such?
Yeah. No, they're getting great on that. But I think them being in Bulgaria helped them. Internet friends in Bulgaria.
Well,
Ronnie, let's give up this whole upside down stuff and go the other way.
I don't think they.
Okay. So I have Alan's presentation. He sent it to me. And it's, he narrated it. So I'll just get that going and we'll enjoy it all together.
This is a presentation about the reanimation and restoration of a 36-inch Bowler and Chivens telescope. Bowler and Chivens made quite a number of excellent telescopes, starting in 1956 through about 1970 or so. This 36-inch telescope was built for Princeton, installed in 1965, and the last project it did was optical SETI, a project with Paul Horowitz at Harvard. Ownership was transferred to the Middleman Foundation. John Briggs and Ken Lowney carefully removed the optics on the first trip in 2013. This is Ken Lowney getting ready to remove the secondary baffle from the Cassegrain focus. The idea was to pack it up and build a new observatory in the Southwest. The next trip in October 2013 to Princeton with John Briggs, Aaron, and Alan Sliskey prepared the telescope for riggers in a crane. We were at the Fitz-Randolph Observatory disassembling the telescope during the 75th anniversary broadcast of Orson Welles' War of the Worlds, which talks about the Princeton Observatory. The last observer up and left in 2002. You can see the shadow of the mouse just below the handbook. It took us 3 days to get the telescope ready for moving. David Middleman visited and took in the scope of the project. He had set forth to do. We had to carefully position the axes and disengage the worm gears so they wouldn't be damaged in transit. The control console is a masterpiece of electromechanical art. The OSHA compliant machinery for the floor elevation drives and the dome rotation were under the floor. This is the relay-based CPU that drove the telescope. There are absolutely no active components to this telescope. We had to do a lot of the work on the right ascension drive, getting it ready to go while working over a hole in the floor. It's about 12 feet down to the lower level. The wiring and construction of the whole telescope was really first class. 2 sets of geared Selson motors drive the RA and serial clock dials on the control console from this right ascension drive assembly. There were a total of 11 motors on the RA drive, plus clutches, differentials, gearboxes, and a lot of wiring. It's a really big telescope. It even has stairs to walk around on it. We got the right ascension drive loose and all the big cables that run through the mount with a very complicated arrangement, all gathered up, ready to go. The rigger showed up with really nice equipment. Here you can see this nice modern crane and came equipped with somebody who knew how to use it. And in short order, we had the pieces leaving the dome, heading for a flatbed truck. We were able to lift out the right ascension drive without any drama after having made some custom lifting brackets. The 11,000-pound polar axis was a little trickier to rig out because they had to get the angle just right. And finally, the base weldment was lifted out through the shutter. The telescope was shipped to Alamogordo, New Mexico, and stored in a warehouse where we checked it out and actually made plans for setting up a direct drive system. David Middleman bought a 19-acre parcel adjacent to New Mexico skies to site the observatory. David Middleman's on the left, Mike Rice is in center, John Briggs and Dennis DeChico on the right. Siting a brand new observatory is, I think, a wonderful thing. And here we are out walking around the ground, some stakes and a theodolite. We had to do a little figuring out. I had brought my little Kern theodolite. It has a lot of wonderful features, and we had to kind of figure out how to use it, but we did. We got everything lined up very nicely. And there's David Middleman having pounded in the corner stake for his new observatory. At that point, it was time to get much more serious about designing everything. As one of the early versions of the roll-off roof observatory. It's all done in SolidWorks in full detail. And here's a more detailed view showing the telescope in the building. The roll-off roof extends over the control room with enough clearance to see the pole. I designed a 7.46 degree wedge, which is the difference between Princeton and Mayhew, New Mexico. The welder was very curious why on earth we needed 7.46 degrees. And he was, we told him it was about all the earth. The telescope was originally set up as an F13 Cassegrain with a very robust focuser shown here and a front ring of rolled steel. This assembly is about 1,000 pounds. made very detailed measurements. I went out and bought a 1 meter vernier caliper, just so I could get a good reading on the bolt circle, and also there's some mating details on on where the flange mates with the telescope. We decided to convert the telescope to a Newtonian, the f4. The mirror is parabolic, so it's a 36-inch f4 Newtonian. And I figured out that I could make a rotating diagonal, so we could have 4 instrument ports, remotely selectable. I found a 10 by 15-inch ULE optical flat on eBay. Looked like the perfect thing. So I designed a rotating diagonal system. This is the carbon fiber plate for the diagonal support. This is the coated ULE flat on the mounting system. The design uses a semiconductor robot motor, and I just the adapter between the motor and the back plate for the diagonal includes tip tilt adjustments should they be necessary. The idea behind this is to have 4 instrument ports that can be remotely selected, so we can have a wide field camera, a planetary camera, spectrograph, and maybe even an eyepiece that can be remotely selected and utilized without being present. This is the SolidWorks design showing the camera, filter wheel, focuser, and the rotating diagonal and all of the mechanism for that, and an enclosure for all the drive electronics. That's the diagonal holder assembled with the tip tilt holder. I tested everything before we anodized the parts. That's Dennis Tachiko helping out. He was curious as to how it was all going to come together. You can see what looks like a very unusual amount of offset for the diagonal flat holder. And that's because of the thickness of the flat and the configuration of a fast Newtonian that requires this offset. I set up the secondary ring on my surface plate so that we could get everything lined up very carefully, nice and square and level. We use a machinist level to get everything lined up nicely. This is the carbon fiber mirror mount installed. And this is the coated diagonal mirror being attached for the first time. We were able to check the collimation with an optical flat mirror placed on the granite table under the diagonal and a laser collimator in the different ports. We used one of Dan Gray's Force One controllers to be able to turn the diagonal, and we tested all that on the bench. This is the home switch for the diagonal rotator and the electronics package that has the Force One controller, power supplies for that, and also the power supplies for the camera and the networking. We run fiber optic Ethernet up to this box and convert it to wired gigabit Ethernet in this box. There is a spring-loaded detent for each of the 4 positions so that it'll hold its position with the power off. This is the whole new front ring tested and ready to go to New Mexico. This is the new front ring on top and the old front ring on the bottom, packed up, ready to go to the shipping center to get trucked to New Mexico. This is the new observatory building, the roll-off roof. It's almost ready, December 2016. We wanted to make sure that we got the telescope exactly north-south so that nobody could tell funny stories about us screwing it up. So Dennis and I set up my little current theodolite. We looked at Polaris and I read off the position of Polaris from the SkyX software. The next day we decided to check our work. So we set the theodolite up again, and to get the telescope aimed correctly, I read off the position of Polaris again. At that 2 o'clock in the afternoon, Dennis dialed in the position on the theodolite, and we found Polaris right on the crosshairs at full daylight, 2 o'clock in the afternoon. We wanted to get the wedge perfectly north-south based on the east-west line we had run through the observatory from the theodolite. We also started installing all the roof drive hardware that I had designed. This is myself and Dennis's feet installing some of the stainless steel plates that hold the bearings for the idler pulley on the roof drive. We then got the telescope base brought up the mountain by John Briggs. We decided to get that installed. We brought it into the observatory with a tractor, and then got it situated on the wedge so that we could start doing the final alignment. We finally got the telescope base onto the wedge in the right place with some pry bars and come-alongs. By the next time we went out there, we had the roof working. We set out to do the fine leveling of the base on the wedge using the push-pull bolts that Bowler and Chivens had conveniently installed for us. I used a machinist level and a sine bar to set the tilt of the telescope base. This is the basically setting the polar angle. It came out within a couple of minutes when we finally did the polar alignment. We made some benches so that we could spread out all the stuff we were working on. We installed some chain idlers to keep the chain from dragging on the roof. And this is the roof drive, which uses a 3-phase motor on a variable frequency drive. And the gray thing you see with all the wires there is what's called a multi-turn limit switch. It has 6 micro switches and a gearbox that and differential so that you can set any of the switches to any place on the travel of the roof. And this keeps all the switches out of the weather. You don't have to have limit switches at the end of the travel out in the weather. John Briggs and the rigging crew set up in Alamogordo to get the telescope out of the warehouse and back onto a flatbed for the ride up the mountain. And this is the 40-foot flatbed filling up with telescope parts quickly. And there's the Bowler and Chivens telescope kit ready to head up the mountain. John Briggs had done a masterful job of keeping track of all the bolts as we took them apart. And then he was able to give them back to the assembling riggers in the order that they were necessary. This is the telescope kit and the assembly tool next to the observatory in Mayhill, New Mexico, getting ready to install it. The first part was the polar axis. We had to lift the polar axis and get it just at the right angle. This is the polar axle flying again. This is me cleaning off the surface and also applying a film of light oil. Next are the right ascension counterweights. It takes a little doing as there's 3 tilts to get just right before it'll bolt up. This is Dennis cleaning the mating surface that'll accept the cell. This is hoisting the 1,200-pound mirror cell up into place. And this is getting the new front ring with the rotating diagonal system ready to go. Through a miracle of fits and tolerances, the 50-year newer part fit perfectly on the old telescope. This is myself, my son Aaron, Dennis DeChico, and John Briggs standing in front of the telescope after it's basically bolted down. And we also thanked the SolidWorks gods because the roof actually closed. We decided to try using a frameless motor to drive the worm gears. Seemed like a good idea at the time. So this is the frameless motor and 40,000 tick encoder on the worm shaft, which is 720 to 1 to the 60-inch worm gear. This is getting ready to machine the stator mounts for the frameless motors. And this is what the motor mounting hardware looks like. And here's all the new parts ready to put together. We made another visit to Mayhill in August 2017 to install the drives. Aaron went into the base of the telescope to get all the cables dressed. It's a very complicated cable system for managing these custom-made cables that run down through the mount. We have many of the original blueprints for the telescope, so Dennis and I were checking them over. This is the right ascension drive, getting ready to put it back in. This is installing the right ascension drive assembly. And this shows the frameless motor and encoder mounted directly on the worm. You can see Dan Gray's Force One controller mounted to the door on the side of the telescope. We had to do a fair amount of wiring for the diagonal rotator and also to hook up the camera, focuser, filter wheel, etc. This is the unusual lightweight Pyro Ceram primary mirror, 37.4 inches. So it was a prototype for balloon astronomy. It was then used for this telescope. We spent quite a bit of effort trying to get the worm gears to behave. We wound up with a stick slip condition that in the end I believe was caused by a change in the moment of inertia of the high-speed part of the drive, mismatched to the inertia of the telescope. This is what that lightweight mirror looks like. It's got a Pyro Ceram front and back with a faceplate of optical glass and hollow Pyro Ceram tubes as spacers that was slumped together and fused together. While we were having trouble with the worm gear drive, I decided to explore direct drive, and I found a matched pair of Siemens motors, again, frameless motors on eBay. I designed mounting hardware so that the direct drive motors and Renishaw absolute encoders could be mounted to the right ascension and declination axes. We built acrylic covers to keep the desert dust out of the encoders. And we had Dan Gray come out and install his Force 2 controller, which will handle a lot more power. Coming up with electric brakes was a bit of a challenge. What I wound up doing was finding Volkswagen rear calipers that had an electric parking brake. And then I cut them in half, made a spacer to adjust the spacing to work with the big worm gears, and made phenolic brake pads. And this is the crew after getting the direct drive system first pass up and running. On the left is my son David. Then in the front is Gary Walker. And then my son Aaron, myself, Dan Gray, and Arnie Hendon. In summary, building a completely new observatory from the bare ground takes a lot of doing. It's quite complicated. We had a lot of effort from many very experienced contributors. Took many years, mostly because it's a part-time effort with otherwise busy people. And now it's time to go do some science. And we're now getting ready for the next phase of doing science. And our inspiration continues with our memory of David Middleman. Thank you.
I'm happy to answer questions.
Oh, good. I was just gonna ask if you were still out there. That's great. So, so is the telescope in exactly the state that you shown in the last part of your presentation, or has more work been done on it since?
A little more work has been done on some of the other peripheral parts of the observatory, like getting weather stations up and running and security cameras and some more tuning on the servos. Dan Gray has been working on it with my son and Gary Walker. More recently, they're getting ready to go out again and spend some more time with it, but it's basically there. It's basically well working. Now we have to go back and, as you reconfigure things, you tend to pay less attention to the cable dressing and stuff. So now you have to go back and shorten up all the wires and put in cable ties and make sure everything's ready for the next years instead of the next days.
What's the science mission for this thing?
That is to be determined. We are presently looking for a partner who will wind up owning the whole works. And it could be an organization like AAVSO, in which case the mission is reasonably clear. Or it could be a museum or a astronomy club or a university. But it's a nice general purpose machine. It's a modern F4 Newtonian with full automation. And it's the mechanical aspects of it are built exceedingly well.
When you went from Casa Grande to Newtonian, you've got a mighty high focus.
Yes, the 12-foot ladder will allow somebody to see through the eyepiece at about 25 degrees above the horizon. It was not intended for any sort of visual use, but we have looked through it.
So Al, I was curious the first time I saw your presentation, and you're trying to get the narration to come through. The length of the right ascension pillar seems so long. Why is it so long?
It's part of the reason is that if you put a giant spectrograph on the back of the telescope, which was its original mission, a 3 or 4 foot long spectrograph, it won't hit the floor.
Right. Okay,
And-
that makes,
That configuration, it's kind of like a German equatorial, but you don't have to flip. Because nothing hits ever. That
Okay.
off-center polar axis is a interesting design. It's complicated. When you look at that telescope, the outer tube is like 24-inch diameter, 3/4-inch wall steel tubing. And all it does is hold the counterweight. It's not attached at the bottom, it's only attached at the top. Inside that is an 18-inch diameter, like 1.5 inch thick wall steel tube, and that carries the bearings, giant ball bearings. And then inside that is like a 12-inch steel tube, which is the actual shaft that transmits the torque. That transmits the torque from the gear to the top. And that's it. It doesn't have to manage the torque of the counterweight. So it's a completely mechanical system, and all of the flexure in all the first order stuff is canceled mechanically, just by brute force.
I have a question. What's that blue thing to your left?
Excuse
That
me?
what's that big blue thing to your left?
Oh, that is my antique telescope.
oh,
Wow.
whoa, that is gorgeous.
So that's a 10-inch Warner and Swayze
Wow.
from 1916. And it now has, I did not get the original lens, the original Clark lens. And after hunting for many years, I found 4 objectives, but nobody would sell me one. So Roger Serragioli, who's an Antique Telescope Society member, made me a new lens, but it's an apochromatic triplet. So
Bit of
now
a-
this telescope is the best of both worlds.
Yeah, wow. That is so cool. Did you know what that was?
Yes, I did.
Yeah, okay, I thought. Okay, everyone here has just turned green. That's cool.
You
Okay,
might get lucky and say, what's the red one behind him?
Oh, that's a car lift.
oh, yeah, there you go. There you go. Okay,
He and his wife.
But there is, you can see here, there's a
Yeah.
5-inch Cook refractor from 1871.
ooh,
I thought it was a missile.
No, that's on the list of
oh,
things.
yeah. Okay. Wow.
Where do you live and what's your gate code? I'm sorry.
I am just west of Boston in Lincoln, Massachusetts.
A beautiful piece of land that they have. It's fantastic. And he's got an amazing shop.
Hmm. Yeah, no doubt. Okay. Any other questions? How about you zoomies out there? Any questions? No? Okay. All right. Thank you, Alan. Very good.
You're most welcome.
All right.
I saw it's looking worse and worse all the time.
Okay, so that was the last presentation for this year's workshop. And so we are now at 4:11 Pacific time. So we were definitely way ahead of schedule because of our reshuffling earlier today, and that's fine. Typically by this point in the workshop, everyone's getting kind of tired. I can certainly say that we're all tired of sitting on these folding chairs here, and we have a lot of sore butts. So I'm going to wrap up with a few minutes of comments tied into what I said when we started out yesterday morning. when I challenged everyone to start thinking about how we might improve this workshop going forward. Now, but before I get there, yeah, I just want to acknowledge every speaker did really a great job. I'm just really thrilled. I mean, really, really well done. You know, one of the things that's been different here in the actual workshop at Dan's TMS is that even though it's rearranged differently, it has exactly the same feel as the old place. But no one brought a big telescope. I think it's the first time that hasn't happened in quite a while. I'm sure we'll change that up next year. Okay, so yeah, as I mentioned yesterday morning, Mel has agreed to become co-chair starting next year. And that is really great news as far as I'm concerned. And hopefully, no, that's not going to work. So anyway, yeah, so with Mel becoming co-chair, I see this workshop becoming more than it has been to date. One of the big things that we've talked about is just the original statement of purpose for this workshop that we came up that I think Russ wrote this. And in part it said bringing together advanced amateurs, professional telescope makers, and astronomers in an informal collaboration. Our goal has been to adopt technologies used in the world's largest telescopes for the design and construction of low-cost, high-performance, 1 to 2 meter amateur telescopes. That was a pretty lofty goal when we first started out, and really some significant progress has been made along those lines. But you know, the workshop has evolved away from that purpose. It's really more, you know, like this workshop, the last 2 days. It's more of a series of, or what are the cool things that amateurs are working on? I mean, they're not all focused on that mission statement. Okay, and that's fine. I mean, that we've evolved in that direction. You know, in the earlier years, there's a lot of work on direct drive that Dan and Dave Rao were working on. And that was a huge project. And that was very much in keeping with the original statement of purpose. Same thing with meniscus mirrors, you know, which is ongoing. And you know, Mel is probably very soon going to start working on those 2 42-inch meniscus blanks. Okay, that's right in the zone. But that's not the whole workshop. And so, you know, Mel and I have been talking about, okay, so, you know, if we really wanted to focus in on that original purpose, really, we would have to we would all be employed by a company doing that. And that would be our purpose. We'd all get big paychecks and be happy and live happily ever after. But that's not the case. So recognizing where we're at is a good way to start planning on how to move into the future. And so maybe a more accurate statement of where we are now is something like the Altaz workshop is designed to bring together amateur telescope and optics makers in an informal setting to showcase their projects with the goal of sharing knowledge and inspiring others. That's, oh, yeah, okay, Dan snapped his fingers in approval. That's good. And after talking with Mel, it's also apparent that we're missing half the equation. I mean, what's a telescope if you don't use it? So including observations. Okay, earlier today, Russ gave us, you know, some brief results of some of his observations. And okay, so that's one kind of observation. Okay, that's science. All right, there's visual observing. There's photography. There's public outreach, inspiring others. Bringing in people to present along those subjects as well as the telescopes we're working on and the technology we're working on, I think will round out this workshop to become more robust, because having the technology and the purpose together, I think will drive us in, well, maybe not drive us in a particular direction, but will give what we present perhaps a broader and deeper meaning at the same time. So, I threw this together as something to add to that statement I just read, and that would continue to say, it's also a forum to share the results of what these telescopes are made for, observations, scientific, visual, photographic, and outreach are the reasons telescopes are made, and sharing noteworthy observations is as important as sharing details of how the telescopes are made. So imagine, Jimmy Lowry, 48-inch telescope in West Texas, having him talk to us about observing gravitational arcs. It's really cool. Steve Gottlieb, the only person I know of, and perhaps ever, who has visually observed the entire NGC catalog and is down to the last 30 objects of the IC catalog, all done visually.
That's huge.
Okay, there's a lot of stories he has to tell, I guarantee. So yeah, and there's many other observers out there as well, not just in the United States, in Western Europe. I mean, I know several people who are fantastic observers. So anyway, so it's something that Mel and I are thinking about. I'm excited about it, you can probably tell. And also the historical aspects, like, John Briggs' presentation about the 40-inch refractor yesterday. Last year we had a presentation about the background of the Hubble mirror debacle. Yeah, debacle. And stuff you just don't generally know, but we're somewhat connected to that because they're telescopes, and we know telescopes. So there's other things we're talking about, and I've heard a couple of ideas from some of you here already today, and I hope everyone who is still listening out there live now or listens to these recordings, if you have ideas, to please contact myself or Mel or someone who knows us and tell us your ideas. We really want to continue to make this a interesting and informative and inspirational event into the future. And given our history, 16 versions of this now, we have a pretty good history, and continuing that forward, I think, is not only be really important, but it's a heck of a lot of fun to get together once a year and touch base and see what we're doing. And I just really hope we can continue to do that and make it even more so. So with that, that's it for 2023 ALTAS workshop. Thank you all for attending here in person and online, and we'll see you next year.
We did have a users group called the Altaz group or something, right?
We'll say what?
A users group for the,
Oh yeah.
is that still alive?
Well, if not really, it's there, but no one uses it.
But maybe that would be a good way to get things going, some kind of a group.
Well, we have a group going, Oregon Scopeworks.
Maybe we should rename this Scopeworks.
There's an echo in here.
The only couple of things. One is that where to do that. So right now, the Oregon Scopeworks is kind of invite only. You might have to open it up. But one of the other options is the I don't, to my knowledge, there isn't an organization called the Altas Initiative, I think, unless Russ copyrighted it or something. But I know at least one of the people that that moderates the group website there, the GiveSci site. Maybe this, or the new, whatever it is, wants to take that over and make it the outwardly facing.
Yeah.
Um,
Yeah. Yeah, maybe so. I mean, there's a number of things we could do along
Yeah.
those lines.
so,
Yeah.
Yeah, just food for thought.
Yeah.
And I think that we should change the name. Because it's not an LDAS workshop.
Exactly.
We had
yes.
one really great talk about an LDAS,
Yeah.
LDAS council
Right,
today, but
yeah.
that's just one out of, you know,
Why limit ourselves
yeah.
with just the title of the group? Yeah.
And I'm hardly excited to, one thing I would like to see is a call out for instrumentation. We had
Yes.
Yeah.
One
Yeah, there you go.
comment about a optical SETI
Hmm.
instrument that got some good discussion going and some head scratching.
Yeah, yeah.
So that would be,
Yeah.
there's not a lot of new instrumentation out there.
Well, but
Spectroscopy next year. Yeah.
there's probably a lot more amateur made instrumentation
There is.
that we don't know about. And this would be a great place to learn more. Yeah. So, yeah.
I just wanted to throw in one observation about the Oregon School Works as an email thing. I know a couple of people who have left the group, just completely unsubscribed because they're overwhelmed by the size of the group and how much chatter is going on it. And it's gotten much bigger than what it was, and it's starting to kind of become another Cloudy Nights of sorts, not on that scale, but just wanted people to be aware of that if you're feeling overwhelmed by the email, well, okay, deal with it in your own way. Who we are as a group that meets every year, I think is quite a bit different than the email chatter that's going on. And I don't know what that means, but how we present ourselves to the outside world probably needs to take that into consideration.
Yes. Well, along those lines, most of us here live nearby. I mean, you guys came from California, so you get the furthest travel award this year. But one of the great things about the Scopeworks list is that we're all over the place.
Yep.
And I think out of the first two people that were at the very first workshop, just Dan and I are here right now.
Yeah.
And I live 30 minutes away. So this is real easy. And so there's even thought, do we need to have an in-person meeting? Could we just do it online? I would vote no. But we did do it 2 years, and it worked pretty good for 2 years. But that was during the worst of COVID.
That's one of the things that's good that came out of COVID. We wouldn't be doing this.
No.
These people online wouldn't be here if it wasn't for COVID.
Exactly.
And this hybrid thing is really nice.
Yeah, look at the diversity we had.
Yeah,
because of it.
yeah.
It's really awesome.
Yeah. But it'd be great to have, telescope makers from Germany or France.
Absolutely. And we can.
Yeah, and we can, but we really haven't. And that's one of the reasons I'm real excited that Mel will be co-chair, is that he has those connections.
I think I'm the furthest traveling, Lonnie and I, of course.
Mhm.
And I gotta tell you, coming to your shop and commingling with the people really means a lot to me. It's a lot more worth it to me than sitting in my house Zooming with you guys. I mean, there's nothing wrong with that, but I'm thrilled that I'm sitting with you guys.
Oh, thrilled you're here.
I appreciate you letting
Yeah,
me do this.
oh,
And
yeah.
it's kind of cool because, he knows Taj.
Yeah.
From Taj helping out or whatever.
Mhm. Yeah.
I mean, I think I've talked to you too.
So I would like to see this.
In this room,
this event becomes something that really does attract people from around the world. It is worth a plane ticket to come to because of the in-person connections you're gonna make, so that you can actually hold in your hand pieces of the LIGO observatory
Yeah,
like
yeah,
we did today.
yeah.
And, you know, so that I think, is part of our outreach, right? To help make those connections and draw them here. And as fun as it is to be in a working machine shop, it's damn cold and it's not all that comfortable. And maybe sometime we grow up to the point where we can rent a space. I don't know. But
Or maybe we don't have it in October, end
we
of
don't have it in
October.
I don't
Yeah.
know. Yeah,
September might be, yeah.
It'd be great to get some of our local people back. I
Yeah.
kind of felt the absence of them.
Yeah, yeah. Not many RCA's here.
Would have been great to
Yeah,
have them with us.
yeah.
Did anybody advertise who they are?
Oh, yeah. Oh, yeah.
Okay.
I kind of like the fact it was in Dan's shop.
Oh, yeah.
Oh, this is a cool
Yeah,
shop.
Yeah.
I like that it's here.
Yeah, when we've held this in July and August in the old shop, it would get super hot.
Yeah.
And we were just melting and people were falling asleep because of the heat. And it's like,
September might be your answer.
September, so best time to do a lot of things. Yeah.
Well, I for one hope you don't get rid of the personal touch of having us here once in a while, because when you get online, just knowing that, you know, having known you personally makes a world of difference. to
Oh,
me.
sure. Personal connections.
Yeah, because that's missing on
Important.
Zoom.
Sure. Sure. Yeah. You can't
So
do.
we weren't here all the time, we still have known.
Yeah.
We're doing it right now, but we're kind of stomping on the people online that probably would love to be talking right now, but because of the mute button, it's just a barrier. And I haven't heard very many people online speak up at all. The questions have been very thin coming from the online people. And, you know, if everybody online right now would get off their mute button and just start shouting into the mic, maybe it'd be a little more interesting. I don't
Well,
know.
you know, yeah, yes, I hope so. But if not, you know, just starting to think about this
Yeah.
is really good. And I'm really encouraged by all your guys' engagement. The conversations Mel and I have been really stimulating. So I think there's a lot here to work with
For sure.
and to expand it and to grow it.
And so let's say we really don't have a user group yet, we don't have a name, but we do have an email list that we can communicate.
That's for
We do, we do. And, you know, I have everyone's name, almost everyone's name on my broadcast email when I send out the announcement and the agenda. I mean, there's like 50 names on there.
I think we can pull all the names from the Altas.
Yeah, yeah.
Probably Oregon so forth.
Yeah, I think, you know, one of the things that, you know, personally is that, you know, starting a new email list or, you know, I don't want to read another email list. I don't think anybody really does.
No.
Um,
I think that's maybe what I was saying, is like, I don't want to start another email list on top of what we've already got.
Yeah.
And have it balloon out of
Yeah.
control.
Right.
Let's just go with what we got.
There must be an overlap between the two lists, though.
Oh, there's a great deal of overlap. I mean, almost everyone,
Providing there might not add that many more people.
I mean, most of the presenters or many of the presenters are on the OSW list. A lot of the people who have been online certainly are. And you know, it's great that we can have in person and online, because you know, sometimes it just doesn't work out where people can come.
Oh, sure.
You know, it just, you know, life gets in the way. So I don't know. It's not like we have to figure everything out right now. It's just, my intent is just to get the gears turning in everyone's mind about ideas that might pop out. And it could be tangential ideas that might spur another idea that could lead to something like, wow, that's perfect. That's exactly what we need to do. So
Just to throw it out there, the Altas is, I've got to think that Russ would be more than happy if that were renamed in the some scope works list.
Yeah, maybe so. Well, we'll be talking with Russ, yeah.
That would let the archives there go with it. Because a lot of the direct drive stuff and a lot of the alt-add stuff is
Yeah.
beneficial.
Yeah.
But that would be, in my, if Oregon Scope Works wants to maintain a little bit of closure, it would allow that and be a venue to public facing.
Yeah,
Oregon Scope Works would be more than, I mean, that'd be great too, if we want to open it up, but I think whatever happens, it's gonna end up with more of a public face.
yeah. It's, Mel moderates the
I know,
OSW list but I don't know that he's ever turned anyone away.
no, but I'm not sure he wants to open it up either.
Yeah,
Well, you don't have to answer that right now. I'm not saying it for that reason.
right.
I'm saying it because the reality is Oregon Scope Works has a nice feel because it's not cloudy nights.
Yeah,
Exactly.
yeah.
And if we're gonna build something that's gonna look more like cloudy nights, and if we wanna put it on cloudy nights, which is probably an option too, so I'm just saying. Then the Altas workshop list is dormant enough right now, it would be okay to kick it
Mhm.
and bring it back to that open.
Yeah,
open
yeah.
view.
Okay.
One thing I really like about the Oregon Scope Works email list is that it's so relevant. And the one complaint I did hear was that, oh geez, I'm trying to solve somebody else's problems and I don't have time for that. And I appreciate that coming from the individual I heard it from, but everybody takes it their own way. It's just a freaking treasure trove. And sometimes I'm overwhelmed and I just have to skip a thread. But I do appreciate that people have been very uncloudy night-like on it and polite, respectful, sticking mostly to the point. And it's been great. So
Yeah.
hopefully we can, if this is gonna grow, I don't know how we steer it so that it doesn't become another cloudy night-like thing. But I wanted people to be aware of that.
Yeah.
I think it's an important
Well,
differentiator.
I mean, the first thing in my mind is that we don't become an organization.
Yeah.
Like Joe was talking earlier today about the hierarchy that he dealt with
All right.
at LIGO and in other places. And no. This is going to be two people are going to put this together. So that's 100% increase in people, which is great. That's enough right there. And the in keeping this simple and pure, I think is a lot easier that way. Because we don't want to have a board, we don't want to have subsections and section leaders and blah blah, none of that stuff. No, thank you. So keeping it simple and on point, however the new statement of purpose actually comes to be, although I am kind of partial to what I put together and read, that may change in the next year. We'll see. And my intent is not to wait until next August when we're putting out the agenda and then the announcement for 2024 workshop. Say, oh, this is what we're going to do. The idea is to put out updates. This is what we think we're going to do. This is why we think it's going to work. Blah blah blah. Any comments? So
I get the sense that even though you're saying people might keep in touch with each other, ultimately, this is an annual gathering, a conference.
yeah,
And that's
face to face, personal relationships.
And most of the time it's gonna be here, except next year it's gonna be at your.
Yeah. Yeah, Dan's gonna fly us all out.
Exactly.
But Dan, when you and Dave Rowe met at one of these workshops years ago and started talking about direct drive, and you guys just off you went and you figured it out. And I don't know if that would have happened if we didn't have an in-person gathering. Yeah. So
Now, I have an opinion about lunch. I think your lunches were fantastic.
you can't beat
I
it for
think- I think
$5.
Lunch is a big draw for this organization.
Plus the beer.
And the
Plus
beer.
And it wasn't mentioned in your invite, you know, you should have an itinerary there.
Have a
On
menu.
your menu.
Well,
This isn't free for Dan. He's been heating the place, and he wouldn't be heating on the weekend if we weren't all here, so that, it actually does cost you for us to be here. I guess it does.
oh, okay. Well, we'll have a registration fee going forward.
Yeah.
And then a board.
The treasurer, you
Top of
know.
one seat.
Plus, I wanted to take the opportunity to thank you guys for the hospitality.
Oh,
Right.
it's been great to have you guys here. Yeah.
We really had a good time.
Oh, good,
Howard.
good. Yeah. Thank you all. Thank you all very much. So, okay, so I'm gonna stop the recording and the meeting right now. Again, thank you to everyone, all the presenters and everyone who tuned in. I think this year's workshop was another great success and look forward to